Hello, my name is Hoon Kang, and welcome to my final project, study in optical character recognition of printed characters, specifically geared toward reading of electric meters. Currently, utility workers may have a need to be physically present when reading the meters or having it read out to them over the phone. This process likely increases vehicle and human foot traffic, along with the possibility of having errors when manually reading the meters, and I'm hoping this solution will help optimize this process. The dataset comes from the Robotic Vision and Imaging Laboratory in Brazil. There are 2,000 high-resolution images, and I actually had to crop them to be able to focus on the meter readings themselves. And you can see the example of that here on the left, which is the original image, and the cropped image on the right, again, to focus on just the meter readings themselves for training purposes. The network uses a connectionist temporal classification, also known as CTC, which uses a convolutional neural network to get the sequence of features and a recurrent neural network to propagate that information through the sequence. It also uses a bidirectional GRU or gated recurrent unit, which helps decide which information should be passed or which information should be forgotten to help with the vanishing gradient issue, which is sometimes prevalent in certain activations such as sigmoid, where the loss can be 0. Now, in going over the technology, I'll be going over the data preparation and pre-processing of the image themselves and providing a sample of the specs associated with the images, as well as a sample of the image that will be inputted into the neural network as you see here. Then I'll be going over the initial training, and the results of the initial training in terms of the accuracy, as well as having an output or visualization of the images, as well as the associated activations from the initial training run. Then I'll be trying to optimize the parameters, as you see here, based on the experiments to see which settings are the best or optimal for our training. And based on that experimentation, I'll rerun the training to see if I could get a better accuracy, which is what I do here. And on top of that, I'll be again going over the various outputs of the images based on the optimized parameters, as well as the associated activations based on that. And then from there, I'll be trying to improve accuracy even further by having data augmentation, as you see here. And you can see a sample of each of the images where I added 2 images per training image in attempts to improve the accuracy. Thank you.